Okay.
Back and forth.
Yes, but maybe a question for you, Larry, because I think thanks for a great presentation. And in my view, we really need very energy efficient carbon capture solutions if we need to do it right. We need a lot of green power from wind and solar and other sources, hydro, of course, since we're here in Norway. But we also need very energy efficient carbon capture solutions. So what do you need to scale your solution up, and how far are you from being at that point? You are working currently at Aalborg University, where we have a large cement factory which emits, I think it's 2.5 million tons of CO2 a year. So to maybe not to that extent, but maybe somewhere in between. How, where are you in terms of doing that?
So we just completed a feasibility study with Aalborg Portland for 500,000 tons per year, and they did a similar study for amines. I'll have to say that Aalborg Portland is one of the worst sites for amines, and the comparison is pretty stark. So we this technology performs much better far better than the amines in that particular installation. It's not typical though. Usually we would be closer, but still separated by a fair distance. So what our technology needs, by far the most important thing, is to build at larger scale and operate for a while and learn what we need to learn. So we've become pretty humble. We know there are things we don't know. We just don't know what they are. So and so we need to build a larger scale facility and operate it a while and learn the things that we should have learned or should have known already, and make modifications and scale it up in operation. So what we need is commercial style operation at a larger scale, and that's coming along, but not as quickly as I would like, but maybe as quickly as it can. So.
Thank you so much. So I was just wondering, Kenneth, would this be something that you could talk about? Do you have any takeaways from Larry's?
Yeah, it's super interesting. We don't have our own technology. We license technology, so if it's working, of course, that's super relevant. So we are already having a discussion on the technology. But of course, if you're going to build a scale, you need to de-risk it. So nobody wants to be first. So I guess, as Larry says, if we can get some help with some larger scale-ups, maybe then with some innovation support from some governments or something to have those bigger references, that's what you need. Then the projects will come. So, yeah. But I think they're also important to say that we don't think there is one technology that will fit every case. It depends on the sites. Sometimes you have energy surplus, sometimes you have cheap electricity, so it will depend, but it really seems promising, that's for sure. Yeah.
Thank you so much. So Geir, you've talked about the incentives and of course how the state could be able to facilitate or make sure that we demonstrate different technologies. Would you have a comment to this?
Yeah, well, I can refer to the technology that was displayed at Rakestad and also at Klemetsrud is shell technology that I know was purchased 14 years ago from a smaller company, tested first at the Scotford upgrader in Canada, and that was in 2012. Okay, so now that technology was first tested in Canada, now it's being deployed and being used by developers like yourselves and others. And when Canada can do it, United States can do it, there's no reason why Norway can't do it. We have enough money to do it. It's a matter of priority and political priorities.
Yeah. So Larry, do you have anything to add to that? And should we, when capture the CO2, use some of it?
So let me just add that the government support is critical, I think, just for the reason that somebody's got to take the technology risk. this is not a technology that's going to make people profit directly. It's a technology that might avoid costs, but it's mostly going to be response to a regulatory demand that is going to be a cost, not a profit for a company. So it leaves them even less incentivized to take the risk to develop the technology. There must be somebody here. I saw that there's still a name tag on the desk, but from Technology Center Mongstad is a good example of a major commitment Norway's made to carbon capture. As I understand it, the philosophy behind that was, well, the way they explained to me in American, they said Americans had a bunch of extra money and decided to go to the moon. We have some money and we're going to solve the world's biggest technical challenge. And I think the implication was one of those is a far more noble enterprise than the other. But that's an example of the type of support that it's going to take. And it's going to take a lot of, you can't expect that every technology is going to work out spectacular. Well, not every project is going to succeed. And in fact, probably the most important thing is to fail as fast as you can, get through the projects and get them to a failure point if you're going to get to one. Find that as soon as you can and move on. So in terms of, there was a second part of your question was
should we use some of the CO2 for...
utilization. So utilization, I'll be the unpopular person perhaps in this. In the long term, it's naive, I think, to think that we are going to find utilization markets that are large enough to make an effect to the climate. That is, the amount of CO2 that we have to capture and store so far exceeds the amount of CO2 that you can reasonably use in almost any market. That in the long term, that's not probably what's going to happen, at least in my view. But in the short term, utilization can be incredibly helpful. So there are many places in the world right now where CO2 sells at a price and there's enough of a market for CO2 that you can quite profitably build a carbon capture system and operate it probably for a decade or two before carbon capture becomes so widespread that the entire market is sensed. So what I imagine the critical role utilization is going to play is to help find those pockets. So as a specific example, in Indonesia is one of the major pulp and paper producers, like Scandinavia used to be, still is, I guess, in some parts, but in Finland. And they need CO2 to do bleaching and there's several steps in the pulp and paper process that need CO2. There's no CO2 available in Indonesia, so CO2 in Indonesia sells for like $500 a ton. It's 10 times more, maybe more than 10 times more than the normal market price for CO2. So with that kind of incentive, people will build and operate technologies, get the knowledge that they need in order to operate in relatively small scale, but still substantial commercial scale systems, what I call merchant scale systems that address a local market, but aren't necessarily going to address climate change in a meaningful way, and get the operational experience that we need, help fund the development of the technology. That is a really critical role. But at least I think it's naive to think that we are going to find a place to reuse the quantities of CO2 that we have to capture in order to change the climate on this planet. And I think I get frustrated sometimes because I get the sense that that's not very widely appreciated by most of the funding agencies or the scientific community. So.
Thank you so much. Unni, would you like to comment on the usage and what Larry Baxter says here?
Yeah, you saw from my presentation that I fully agree with you, although I work with CO2 conversion processes, that CCU is not going to mitigate the problem we have of excess of CO2 emissions. But I must say that I was very pleased to hear that your technology, for instance, and also the technology that you use, that they are food grade, because that means that we have this immediate use of CO2 directly. We've had, as we saw from Armin's talk, that we've had this CO2 crisis, and it's not only the beer industry. Of course, in Norway we use CO2 to buffer water so that we can clean it without too much chlorine. So I mean there are uses, and I think that the CO2 conversion technology, unless of course if you have a surplus of renewable energy and CO2 source, then it can be make a very positive impact. But on the large scale, if we think of today's electricity production worldwide, where much of it is based on fossil, and well, then it's not feasible. So I think that it is in the post 2050 society that we will see these CO2 conversion processes at the commercial scale. But then also I've been in research so long now that I know that that's the time we need to make really competitive technologies that are energy optimized. So I'm not pessimistic about that.
So, but there's an urgent need for research and development as far as moving forward, and this will take some time, and it will take development and demonstration of the different types of technologies in order to move on further. Så jeg tar litt grann på norsk også underveis her. Det jo ingen tvil om at det stemning for å lagre en del av denne CO2-en, men vi har et tidsvindu som at også bruken vil kunne muliggjøre og legge til rette for utvikling av CCS-verdikjeder, og i denne tilfellet da også CCUS-verdikjeder. Jeg vil minne om at det mulig å stille spørsmål også underveis, bare gi et lite tegn. So I just took a little my liberation to translate a little. Sure.
Hello, Bernd here from Maritime Protection. I'm in a different end of the scale. I'm not talking about the scale-up opportunity of your technology, Larry. And since Chart is the owner now of the company, how about the other scale? Do you think it's going to be portable, smaller devices available for typical marine industry or other transport industry with your technology?
Yeah, I'll just speak loudly. I don't need the mic, but we need it. All right. So I think that this is going to be true of all technologies. Is so that operating at 30 to 100, maybe 150 tons per day. I think there's actually quite a few opportunities right now for systems of that size to contribute to local or regional CO2 needs. It might be, so every time there is a World Cup for soccer, wherever it's held, they run out of CO2 locally. I'm not sure what they do with it all, but I think they can't sell beer anymore because they're out of CO2 for the beers. But there are lots of kind of local markets all around the globe that would sustain systems like that. And we think we can build those. They're not as efficient as the very large-scale ones, but they can still be made quite efficiently. And I think there are quite a number of markets that you could actually build one on a commercial basis without a subsidy and be able to make it work. So that's I call that the merchant scale, and that's kind of the smallest commercial scale that makes sense. And from there you move up to treating everything from a large industrial source. That's already too much CO2 for any imaginable utilization that I can think of. And when you get to utility scale, which is many thousands of tons per day, that's just way beyond what any reasonable utilization technology could do. So.
Thank you so much. So Unni.
We have one more question.
Oh, okay, sure.
Hey, Larry, can you say anything about the TECO 2030 project or arrangement?
Sure.
Sort of following up on Bernd's question about scale.
So so we're talking, make sure I'm understanding the right thing. This is the shipping stuff, right? So you must be familiar. You know that we've been working on. So our technology right now is really targeting continuous point sources, which it's hard to start and stop processes like this. So it has to be continuous, but it doesn't necessarily have to be a point source. So well, at least it could be a moving continuous source like a ship. And shipping is looking for solutions, and we have done quite a bit of work. We have quite a few advantages. The footprint of this technology and the weight of the material, both the volume and the weight are small. It's critically important to shipping. Both of those parameters are very important. Probably more important technically, this might be fun for people who haven't thought about this. So if you're using a distillation column or an absorption column on something that is rolling on the ocean, the column is not working, and then working, and then not working, and it goes back and forth like this. So, and that's and also the variability of the flow rates. So distillation columns are usually the best, or absorption columns. They're very efficient at what they do, but they are very difficult to scale dynamically. So in our process, we have the provisions of our process make it so it's much less susceptible to the pitching and rolling of something, and it can manage, because we've developed this dynamic energy storage version of it. We can manage the dynamics of the changes in flow rates that would happen on any kind of transport. You do it on ships or trains or something like that. So there is some extension of this technology to transport sources, but and it looks reasonably promising. What looks especially promising is if you're doing shipping, the first and most obvious step in my mind is if you convert the ship to LNG powered instead of bunker fuel or something, that already drops the CO2 emission without doing anything else. That drops the CO2 emission by a measurable amount. If you're doing LNG, you have to vaporize the LNG, and that's conveniently at about the same temperature that we need to refrigerate flue gas. And so if you use the vaporization as the refrigeration source in our process, I think we told you before that we could do 40 or 50%. I think we can do 70% capture of the CO2 in a ship without any refrigeration units, just using the LNG as the refrigeration. So that saves a lot of energy and equipment. So figuring out where to store the CO2 on board and how to offload it are some of the things that are still not obvious to me. I think it's inevitable. You're just going to have to give up some cargo space for CO2 storage. But some thought, can you put CO2 in one end of a LNG tank and push the LNG out the other end and store it in the same tank? But we don't see an obvious way to make that work. But that would be great if it did work. So the problem is that LNG is so much colder than the CO2, it will just freeze the CO2 into a block, and it takes a long time to melt a block of CO2 that size. So.
Yeah, continue to finding the right solutions here. Yeah, that'd be. I can't see any follow-up questions, so I'm going to continue to Unni. We've talked about, or you talked about in your presentation about the recycling of the CO2, some part of it, and then the decarbonization of the industry. Would you like to comment on the importance of this part, and in addition to a CCU perspective?
Yes, sure. First, I fully agree, of course, that we can't use all of the existing CO2 emissions to CCU, so it's just part of the solutions, as basically every climate solution is just part of the solution. But I think CCU is most important for the products that are produced, producing e-fuels for aviation or e-plastics or other more advanced materials, and not necessarily, it's not really decarbonizing the industry. So therefore, we have suggested that the reporting of CO2 emissions should remain the responsibility of the industry sector, to ensure that the industry sector is decarbonizing as well, going into CCS, hydrogen, or direct electrification, whatever is suitable. So in the end game, as I said, the CO2 should come from either biogenic sources or directly captured from the air.
Yeah, so that's an important part. But we do have a lot of biogenic emitters in Norway, and of course also in Sweden, and we have a system there that they actually have figured out how they can use this in a market sort of way. Would you comment on that?
Yes. Well, in Norway we have 8 industrial point sources with biogenic emissions of more than 100,000 tons. So huge potential there, and you are also investigating the smaller point sources. What you are referring to in Sweden, the reversed auction, that's for CDR, carbon dioxide removals. And it's a framework to finance permanent storage of that CO2. And we have also suggested a framework for and politics for that in Norway as well, and reverse auctions or carbon contracts for differences are also very suited to have carbon removal projects in Norway.
Thank you so much. Så omvendte auksjoner da er det som er foreslått og kommet gjennom i Sverige, som da kommer i tredje kraft fra med neste år, eller det kommer på anbudet til neste år. Either up in North, you have this renewable energy available, or you should be having it in the future. And of course, for the company that you're leading, the carbon development company, would you care to say some about your plans and how you look into making these products as green as possible for the future?
Well, to make our products green, well, Bergen Carbon Solution, of course, uses CO2 to produce the carbon nanofibers. And I think already there, you start to have this green component. They actually remove CO2 from the environment around us in this production. They take the CO2 molecule, they split it, so you're left with carbon and oxygen as the two products, as you can say. And when we mix this carbon nanofibers into other materials, already there you start to reduce the environmental footprint that the material will have, because you can, well, this is part of the PR strategy, but you can kind of say that, you know, this product has removed, for example, so much CO2 in its production. And in that way you can say that we have a greener footprint, of course. And I think if we can include more CO2-based materials in this way, then this can also aid in reducing the environmental footprint that we have in the material sector. And I would also like to comment, I don't know, I would suggest, if you haven't read it, this International Energy Agency's report on critical minerals in the green shift, which states quite a bit about what we're facing in the years ahead because of the green transition. And we really do need a lot of new materials in the future. And I think this, in part as well, should be considered in terms of the CCU industry. Yeah, because it can actually be have a positive impact there. Yeah.
And also in the application that you talked about, Grønn Plattform, that you have a lot of different things that you actually are going to look at in a product and development phase with different actors. Yeah.
And also in terms of, for example, batteries, we are now facing a shortage on lithium. So what are we going to do with batteries, for example? And here, if you can develop CO2-based materials, you have unlimited access to CO2, basically, then why shouldn't we look into this if we have the technology for it?
Wonderful. So there's a question, Christian.
Hello, Søren Kitteldal from Advent Technologies. We're talking about CO2 capture here, and I hear a bit that we may not be able to utilize all the CO2 that we capture. But if we look at it long-term wise, we want to replace all the oil in the world with another fuel coming from production somehow. That's a huge amount of CO2 that we need to put into that. So I'm thinking there must be more than enough need for the CO2. Just looking at the methanol production in the world today, there is a huge amount of methanol produced from grey industry. Replacing that alone would probably, for the next 40 years, be more than enough for this carbon capture to have its own life. And this is not only the only thing that we need to really. We need to replace all the oil. So if we look at it from a holistic view, where should we spend our CO2 today to get the best effort fast enough to be able to move that transition forward fast?
Great question. Thank you so much. Is there anyone you Unni would like to answer? Give it.
Yeah, well, I don't agree on the premise. We are not to
You can't replace.
Yeah, can't replace all oil with e-fuels or CCU products. We need to do all climate solutions. So electrification first in the transport sector, and we're doing hydrogen and CCU. So we're doing everything here, even sustainable biofuels. So that's my main answer to that. And it's getting very late, so I can't follow my own thoughts anymore. I had another point. I think that was the time frame. Where to start? I think it's smart to start where we have framework conditions and a business case, and that is in e-fuels, basically, in the EU.
Thank you so much. Geir,
We have two questions.
Yeah, but just
Men får svara.
Yeah, just to answer from my point of view, if you look at the scientists and the goals they have, the scenarios they made, there's no chance we can make the 2-degree goal without carbon capture and storage. So basically, we are way beyond the point where we can just recycle what we already have in the atmosphere. We need to reduce it. Yeah. That goes without saying. So we need to remove CO2. But how to get started, on my point of view, I think we should, we talk about CCU as a transition. We need to get started on the CCS, but then if we start with CCU and the business cases with food grade CO2 and of course sustainable aviation fuels, we can get the industry started, and then this will kickstart the whole process. And then I can comment on the fees we are getting. So now the Norwegian government, they are thinking of inducing fees on the emissions, and that is very good. But you cannot go to a pension fund or an infrastructure fund and say, can you build a plant for me because I will reduce my fees based on that. That's not money. You need to get some other incentives as well. So if you are introducing fees, you must also make sure that the company that you get this fee, they can get this money from somewhere else, basically from the products. So I think it's from waste incineration point of view, silly to just put fees on that part of the value chain, because you have producers of plastic, you have people throwing trash, you have the incinerators trying to clean this mess up, you capture the CO2, you ship it to e-fuel producers, and you fly to Gran Canaria to go on vacation, and then the waste incinerator need to pay for the fee.
Thank you.
Yeah.
Thank you, Kenneth.
Thank you.
Getting all fired up here. Geir, he was...
So if I had a kilo of CO2 now, I would give it to Armin. Because I have an old fridge from 1939 at home, has R114 Freon refrigerant, which has a global warming potential of roughly 8,700. So 1 kilo yields 8,700 released. When that fridge breaks and that R114 is released, maybe it has half a kilo. If it had CO2 in it, you reduce that down almost to nothing. So that would be the most beneficial use of that kilo of CO2. And it's the same thing with electricity. If you have renewable electricity, so you could send it offshore to oil and gas, and usually it'll tend to release 3 kilowatt hours of natural gas for exports. If you do that with offshore wind, you actually grow the renewable production. You still release the gas. You could use, with excess of electricity, you need 2 kilowatt hours to produce a kilowatt hour of ammonia through hydrogen and ammonia production. So Nordland County did a study on how to best utilize your electricity, and the same goes for CO2. So I think in scenario planning, we need you, because storage and transport's not going to be there for large scale, but there's no way we're going to reach 2030 targets or 2050 targets in Europe without massive storage. So, it goes hand in hand. The skill sets that's brought through utilization and all the fuels, products, nanomaterials, vitally important. But it's kind of besides the point in terms of the amount of CO2 we need to store by 2030 and by 2050.
So this is too quickly coming to an end, but Larry, you will have to
make one
comment to that.
I think agree with everything everybody said, but let me just at least explain from my muddled viewpoint this carbon cycle that you're talking about. So you don't have to have a technical background to appreciate that most of these cycles start with electricity to make hydrogen, to combine with CO2, to make fuel, frequently to make electricity, right? And there are inefficiencies, large inefficiencies in several of those steps. And so there just isn't, it's just not possible to recycle the system that way. So I'm actually involved in some projects that do that, and it does make sense. But the only time that I know of that it makes sense is when there is nothing else to do with that electricity. And that happens frequently when, especially in this area. So Norway is the beneficiary of this, so it's not uncommon that Denmark, for example, produces more wind energy than they can consume in their grid. And the price for energy actually goes negative in Denmark, and Norway, being smart Norwegians, they accept that negative price and import a lot of energy here and pump the water back up onto the mountains, and then they let it run down again in a few days and sell the energy back to Denmark at a much higher price. So if you don't have any other thing to do with your electricity, like Denmark frequently doesn't, then it makes some sense to use it to make some hydrogen, to make some fuel, at least economically. What still doesn't make thermodynamic sense, but it makes economic sense to do that. And so there are times when you can make fuels, but if you leave fuels out of the picture, and I've done this calculation many times, you look at all of the products we manufacture that contain carbon, and this is plastics, chemicals, fertilizers, large markets, right? These are big industries. The sum of all of that carbon represents about 3% of the CO2 we put into the atmosphere every year. So if you were going to find an industry that was going to make a large impact on that, it would have to be 30 times larger than the sum of all of the fertilizer, chemical, plastics, all the other industries, and just from a market standpoint, that's just not going to happen, right? And so that's not to say that utilization technologies don't have their place. If you can find a way to utilize CO2 that makes sense, you should do that, and everybody should support that, realizing that those opportunities, if you add them all up together, all around the globe, are going to be a very small contribution to a climate change kind of contribution to CO2. They might be pretty important to a local condition, but from a climate change standpoint, there's just not a realistic way for those to grow that large and capture and use that much CO2.
We will let that be the last discussion or the last comment for this panel discussion, because most good things come to an end. But thank you all so much for answering these questions and for your presentations earlier. I will let you walk down, and then we'll have a sum up, and I have one more comment before we wrap up today's. Thank you so much. Så da håper jeg at vi kan fortsette den diskusjonen og de spørsmålene, og fortsette å undre oss og lure på om vi skal lagre CO2-en, om vi skal bruke CO2-en, eller om det er rom for begge. Jeg tenker vi kommer litt nærmere en konklusjon. Det har vært en helt fabelaktig dag. Vi er cirka halvveis i denne konferansen som går fra lunsj til lunsj. Jeg tenker at NTVA og GCE Node og Herøya Industripark har satt sammen en veldig flott konferanse med mye spennende innhold, og ikke minst alt som kommer fra dere som holder innlegg her. Jeg har i hvert fall lært mye nytt, og det håper jeg dere også har, og at vi kan fortsette dialogen etterpå. Og så har president i NTVA, Torbjørn Digernes, bedt om ordet for å fortsette denne dialogen inn i middagen. Mens det kommer opp, så kan jeg også si en ting til, og det at utenfor døra ved resepsjonen så står det nå en racerbil, en elektrisk racerbil, og den står der til i morgen, som dere kan gå og se på, som helt sikkert kan være spennende å gå innom.
Ja, jeg skal ikke holde dere lenge, og grunnen til at jeg ba om å få si noen ord nå, at jeg gjerne vil invitere til en dialog i løpet av kvelden med dere i mindre grupper. Og det har litt sammenheng med at dette akademiet som dere ser henger der, vi har virksomheter av denne typen, som dere har vært med på nå, altså lage møteplasser hvor vi har industri, hvor forskning og utdanning møtes. Vi lager bøker, dere har sett noen eksempler på det, vi delt ut her, og vi har masse fagmøter, og dette materialet ligger på nettet. Dere finner mye om oss på nettet. Men grunnen til at jeg vil si noe nå, at vi har noe som heter NTVAs industrielle råd, som et medlemsråd som består av industribedrifter, av forskningsinstitutter og av universitet, høyskole, institusjoner. Og dette, vi har vel litt under 40, eller rundt 40 medlemmer i dette rådet. Og vi bruker dette rådet som kall det et sounding board, og en link til samfunnsrelevante problemstillinger, som vi gjerne plukker opp som ideer til, og som vi lar påvirke den aktiviteten vi driver, for å formidle teknologi til de som har bruk for å ha den kunnskapen. Vi kommer i den kommende perioden, så kommer fokuset til å bli skiftet ganske kraftig mot det grønne skiftet, og det som altså det vi har snakket om her, og utvidet i scope, slik at det omfatter hele problemstillingen rundt det grønne skiftet. Vi har tenkt på ett spesielt tiltak som vi skal prøve ut, nemlig å invitere medlemsinstitusjonene og selskapene i industrielt råd til å plukke ut noen av sine yngre medarbeidere, gjerne folk som involvert i innovasjon på universitets- og instituttsida, som driver forskning på industrirelevante problemstillinger, og invitere de til å sette seg sammen i workshops for å diskutere at vi kan få til kunnskapsoverføring mellom industri, forskning og utdanning. Det er ett eksempel, men ellers så lytter vi også til alle andre innspill vi får i forhold til å ta opp ideer. Så hvis det er noen som er interessert i å snakke med oss om det, så er vi tilgjengelige her i dag. Ved siden av meg her har jeg Hans Kårflø, som leder i Industrielt råd. Han er fra Tekna selv, men er altså leder av dette rådet. Og Tor Inge Våg har dere sett. Du kan reise deg opp, Tor Inge. Og Lisa Marie Husby. Disse to er vårt eminente sekretariat, som holder i trådene på prosesser som vi driver. Så alle vi fire kan være med og være dialogpartnere.
Ja. Da skal jeg bare henge litt på det. Jeg har ikke så mye å tillegge til det Torbjørn sa her, men I god innovasjonstankegang så det sånn at spør kunden, har jeg lært meg, det en magisk teknikk. Den funker nesten alltid, vil si den funker alltid. Så vi veldig interessert I å kunne utvikle vår dialog med både bedrifter og akademiske institusjoner for å finne de nøklene til hvordan vi kan skape verdier I fellesskap. Det for så vidt heller ingen hemmelighet at vi over tid gjerne vil utvide medlemsantallet I industrielt råd. Det både fordi at dette en veldig god kilde for oss, for kunnskap, for å forstå hva slags informasjon, kunnskap vi skal formidle også til politikere. Og så det selvfølgelig sånn at medlemsavgiftene fra medlemmene I industrielt råd en del av driftsgrunnlaget vårt, som gjør at vi ved å få flere medlemmer kan skape flere tilbud. Men først og fremst nå så ønsker vi å forstå hvor verdiskapingspotensialet ligger I dialog med næringslivet. Og det også sånn, kan jeg nevne Torbjørn, at det jo ikke bare forskere som medlem av, altså I vårt industrielle råd, men det også næringslivsledere. Så vi har dette doble grunnlaget for vår drift, næringsliv og forskning. Så vi snakker gjerne med de som har noe å meddele til oss, og da tror jeg vi skal runde av denne lille presentasjonen her, fordi møtelederen ser veldig utålmodig ut, og da snakker vi sammen til middag, håper jeg. Men noe av det. Takk.
Tusen takk.
Yes.
Klokken 7, så da rekker man akkurat å pudre nesen. Så takk for I dag, alle sammen.